Hi, it's Sarah, co-founder of UMNI, and today I'm going to show you how to get a ground thermal property report using our app. To access our app, you can go to our homepage, umni.ca, and click Sign In. If you already have an account, you can log in, or you can sign up for a free thermal property report. This will take you to our main dashboard. Here I have all of my historical results where I can easily click and reopen any of my past reports. I also have some quick links here for some of the validation, accuracy, and methodology. And you can also find that information here for temperature and for thermal conductivity predictors. Up here you'll also find pricing and the logout button. To generate a new report, I click Start New Borehole. I can choose to enter either the latitude and longitude of my location, an address, or I can select it on a map. Let me, just for fun, select Winnipeg. I can also zoom in and choose a more specific location. Now, if I clicked only temperature here, I can get the full ground temperature profile by depth and season from just that input of location. But I can also select with thermal properties to get a bit more detail. Let me select this one. This takes you to our thermal properties input page, where I'm building up a ground or soil layer profile for the machine learning model to read. I can use either feet or meters to build up this depth. I'm going to stick with meters. So reading off a geotechnical report or a geological survey of the soil lithology, I can easily get this information. But let me just, for example, make this up off the top of my head. So let's say from 0 to 2 meters, that's my shallow realm, I'm going to have a sandy silt. And I have to enter the water saturation percentage here because it is automatically set to 50% for all of the soil layers at this time. I can also edit any of these other properties which are auto-filled from our library of soil and rock types. So I'm going to leave it as sandy silt, 50% saturated for this region. Next, I'm going to do down to 10 meters and say that that one is now clay, and we're getting a little more saturated at 60%. Then I have a soil layer from 10 to 50 meters, and that one is going to be a full sandy clay, and it's 100% saturated. Let's say 10 meters is where my water table was found. And then after 50 meters, I'm going to say that that's where the bedrock is starting to show up. And I'm just making this up. I'm going to say it's a shale average bedrock, and it's 50% saturated. Now I have the chance to review my inputs, which all look good to me, so I will click Get Results. This is asking me if I'm sure that I want to use one of my predictions on this test, and I select Yes. Now the machine learning model is generating the results, and I'm not going to speed this up at all so that you can see exactly how long it might take. It does depend on the speed of your internet, but it could take a few minutes down to a few seconds if you have a really quick internet. That's how long it took for me. So now I have the chance to use imperial units for all of these results, or I can deselect that and it'll be metric units automatically. If I have imperial units selected and I click Download CSV, that CSV will have all of the raw data automatically converted into imperial units. Same thing would be true if it's at metric. So I can download all of the raw data from this report. I can also, and this is an optional add-on, have a print report generated which shows all of the results that I have from this thermal property study. Going down to the borehole averages table, which is a really important result, this takes the averages across the depth for all of the thermal properties. And we also have seasonal averages. If I want to study a specific depth range, I can enter that here and it will automatically update this table using a linear interpolated average. So let's say that I just am interested in the first 5 meters, so 0 to 5 meters. Now what happened is that we're seeing the seasonal effects on these properties. You'll notice that these thermal conductivity, diffusivity, resistivity, specific heat capacity, and wet bulk density may change with temperature in the seasonal range. That's because these properties are calculated as temperature dependent. Of course, the temperature as well will change in the seasonal realm in this shallow zone. Let's say that I'm moving into the deeper zone and I'm only interested in a borehole average between 50 to 200 meters. Now we can see that the seasonal temperature does not change in that depth, and we have constant annual averages for all of these properties with no seasonal effects. This would be useful if I was, for example, designing a geo-exchange system and I could take the thermal conductivity and the average annual temperature and use that in a design tool. Scrolling down, I have all of those results shown now as graphs, and I can just scroll my mouse right over any of these points and get the actual data for them. What we're seeing here is at 150 meters, so that's the number at the top, the temperature that we predict is 7.6 degrees Celsius, and we predict a standard upper and lower error bound for this region. That error bound will change depending on the site that you choose, and it is dependent on the amount of accuracy that we have in different conditions. Scrolling down, we have the full thermal properties, which have some seasonal variations, and also a standard error here for the thermal conductivity. Here is a summary of my ground profile inputs. I can click Start Over to generate a new report, or to study this same location with a different ground profile to see what that does to the results. And that's how easy it is. Thanks for watching.